Lesson 11, using equations to solve problems. So on 11.1, we have a tape diagram, and number 1 wants you to write a story that could be represented by this tape diagram. So make sure you pay attention to the details in the tape diagram and think about what this could possibly represent. Okay, so one example would be that a baker put a amount of cookies in each of 3 boxes. Then the baker put 2 more cookies in each box, and there was a total of 24 cookies in the 3 boxes. So on number 2, it wants you to write an equation that could be represented by the tape diagram. So I know I have 3 sets or 3 groups of the same thing. So I have a plus 2, and I have 3 groups of that. And I know those 3 groups give me a total of 24. So my equation would be 3 times a plus 2 is equal to 24. Or you could write 3 times a plus 6 is equal to 24. And once you apply the distributive method, that's the exact same equation. On 11.2, Tyler is making invitations to the fair. He has already made some of the invitations, and he wants to finish the rest of them within a week. He is trying to spread out the remaining work to make the same number of invitations each day. Tyler draws a diagram to represent the situation. A, explain how each part of the situation is represented in Tyler's diagram. So we have how many total invitations Tyler is trying to make. So here are 122 is what represents the total invitations. How many invitations has he made already? What tells us that he's already made some, so this 66 is going to represent how many invitations have already been made. And then how many days he has to finish the invitations. We know he's going to finish them within a week, and he wants to spread it out to do the same on each day. So each of these sections of X represent my invitations on each day. So that would be the 7 boxes of X is where that's represented. So on B, it says how many invitations should Tyler make each day to finish his goal within a week? So looking back at our diagram, it wants to know how many invitations Tyler needs to make each day. So I know he needs to make 122. He's already made 66. So first I need to know how many he needs to make in those 7 days. So since he needs 122, he has already made 66. So that leaves me with 56 invitations that I need to make over 7 days. So I know I want to make those equally over the 7 days, so I can just divide, which tells me that I need to make 8 invitations each day. So 8 invitations per day. On C, it says use Tyler's diagram to write an equation that represents the situation. So we see that our total was 122, and then everything inside the rectangle combined through addition gives me the 122. So I had 7 days of X invitations each. So there's 1, 2, 3, 4, 5, 6, 7, plus I had 66 that I had already made, and all of that gives me a total of 122 invitations. So there's one way to write the equation, or we could simplify that. So I have X being added 7 times, so that would just be 7 times X plus 66 is equal to 122. D says show how to solve your equation. So if I have my equation, and then I want to solve it. So remember, when I solve equations, I use inverse operations, and then I follow my order of operations backwards. So I have multiplication and then addition. Following my order of operations, I would want to solve the multiplication first and then the addition. But since I'm solving for an unknown in my equation, I want to work backwards. So first I want to do the addition, but I have to use the inverse. So I want to subtract 66 from both sides. So 66 plus 66 and then minus 66 gives me 0. So I'm left with 7x is equal to 122 minus 66, which gives you 56. And then since I'm multiplying 7 times x, the inverse of multiplication is division. So divide both sides by 7. So that leaves me with x is equal to 56 divided by 7, which is 8. On number 2, Noah and his sister are making prize bags for a game at the fair. Noah is putting 7 pencil erasers in each bag. His sister is putting in some number of stickers. After filling 3 of the bags, they have used a total of 57 items. Explain how the diagram represents the situation. Okay, so it says they're filling 3 bags. So I know that Noah put 7 pencil erasers in each bag. So my 3 7s represent the number of pencil erasers in each bag. And then it tells me that Noah's sister added in a number of stickers. It doesn't say in each bag, but since Noah did and then his sister put some number of stickers in too, that lets me know that it's in each bag. Plus my diagram has an unknown amount 3 times. So my X represents the number of stickers in each bag. And then I have my 57. So that represents the total number of items in the 3 bags. On B, it says Noah writes the equation 3 times x plus 7 is equal to 57 to represent the situation. Do you agree with him and explain your reasoning? So yes, we should agree with Noah because there are 3 bags. So this 3 represents the 3 bags. And inside each bag, I have a certain number of stickers plus 7 pencil erasers inside each bag. And altogether, I have 57 total items. So yes, that equation represents the situation. On C, it says how many stickers is Noah's sister putting in each prize bag? So I know that I have a total of 57 items in 3 bags. So there's 2 different ways you can solve your equation. So we have 3 times x plus 7 is equal to 57. Or we can apply the distributive property and go ahead and expand that out. So when I distribute my 3, I have 3 times x, which is 3x. And then 3 times 7, which is 21. And then I have a total of 57. So if I use the equation without the distributive property, first I want to go ahead and divide both sides by 3. So I know how many total items are in each of the bags. So 57 divided by 3 tells me that there are a total of 19 items in each bag. So now, since I have addition, I want to use the inverse. So I'm going to subtract 7 from both sides. So 19 minus 7 is 12. So that tells me that there are 12 stickers in each bag. Now, if you had solved the equation using the distributive property, now that you've distributed, now I want to do subtraction first. So I want to subtract 21 from both sides. So that gives me 3 times x is equal to 57 minus 21, which is 36. And now I can divide both sides by 3. And that tells me that X is equal to 36 divided by 3, which is also 12. So she's putting 12 stickers in each bag. On number 3, it says a family of 6 is going to the fair. They have a coupon for $1.50 off each ticket. If they pay $46.50 for all their tickets, how much does the ticket cost without the coupon? And it says if you get stuck, consider drawing a diagram or equation. So we know that we have a family of 6, a coupon for $1.50 off each ticket, and then they pay $46.50 for their tickets, and that's after the discount. So we want to figure out how much the ticket cost without the coupon. So we know the cost of a ticket without the coupon. We don't know that, so we know we need to use a variable for that. So we'll just use T for this problem. So T represents the cost without coupon. So ticket cost without coupon. Okay, and they have a coupon for each ticket, so I know that they used a coupon of $1.50 for each of the 6 tickets. And then I know they purchased 6 total tickets. So for each cost of the ticket, we had to remove $1.50 off of that for the coupon. And we bought 6 of these tickets. So the cost of the discounted ticket would be T minus $1.50. And we purchased 6 of those and spent a total of $46.50. So now I have my equation. So I can figure out what the cost of that ticket is before the coupon is applied. So again, I can use either method. I can use the distributive, or I can just divide both sides by 6. So if I divide both sides by 6, that's going to tell me what the discounted cost of the ticket was for each person. So that leaves me with T minus $1.50 is equal to $46.50 divided by 6. Okay, so $46.50 divided by 6 is $7.75. So $7.75 is what each person paid for their ticket after the coupon. So I want to know the price before the coupon. So I just want to solve for T by using inverse operations. So I have $1.50, so I want to subtract add $1.50 to each side, because they had a discount of $1.50, and this is after the discount. So I need to know what it was originally. So I need to add the price of that coupon back to the price. So $7.75 plus $1.50 tells me that each ticket is originally $9.25.